You there! Have you heard of Gauss? Do I have news for you? Ever had problems working with pesky vector fields, newfangled electricity, gravity, hair loss, scurvy? Gauss's law is a revolutionary cure-all. The flux of any field will be yours in an instant. Now, you just need two things to be able to apply this law: half a brain and the formula. You see, the left-hand equation allows you to calculate the total flux through any surface using the electric field or the enclosed charge, while the right-hand equation allows you to calculate the gravitational flux through a surface. The law states that the gravitational flux through any closed surface is proportional to the enclosed mass. In fact, Gauss's law for gravity has the exact same relation to Newton's law as the law for electricity has to Coulomb's law. It's good enough for Newton, it's good enough for you. As you can see, it's possible to derive Newton's law from Gauss's law for gravity. Is there anything Gauss's law can't do? And it isn't just closed surfaces that this law applies to. A line of mass, a plane of mass, just apply some imagination. Picture a cylinder around your line of mass and use that as a closed surface. Or imagine a cube intersecting the plane. The possibilities are endless. I can see you aren't convinced though. So how about a second? Yes, you heard me. A second law. To limited time offer only Gauss's law in both its integral and differential form. Now, you might be asking why. Why would I need two laws? Well, why wouldn't you? It offers more flexibility when dealing with problems. The first law, the integral form, is quite apt at dealing with closed surfaces and vector fields, etc., while the differential form is great at giving information about divergence. There are times where one will be more useful than the other, so it's more than worth having both. What is divergence, though? If you want to be technical, it is the net outflow per unit volume evaluated at a point. Technicalities are boring, though. Here it is in layman's terms. While flux can be thought of as the amount of stuff going through an area, divergence can be thought of as the amount of stuff going towards or away from a point. If you want to get down with the lingo, points of negative divergence are called sinks, and points with positive divergence are called sources. I must say though, the best part about all of this is the laws can be derived from each other. Simply spiffing. Now isn't that neat? It's wonderful, a must-have for any aspiring natural philosopher, and it can be yours for only £8.14.